This instructional video is designed to show you how to determine what happens to orbitals of an atom when it undergoes a particular type of hybridization. In this case, we have bromine undergoing D2sp3 hybridization. And it's important to have a proper electron configuration written out in order to start the before and after process. So, we draw the before picture based on what we have here, bearing in mind that because this is DSP type hybrids, we need a d orbital that's the same type as our principal quantum number on our SCP. So we'll be using 4D for the hybrids. Now what that means then is that when we draw this out, we have our 4s, 1, 2. We have our 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have our 4P, 1, 2, 3, 4, 5. And we have our 4D. Now 4D is completely empty. In the next step, which is the selection phase, we want to make sure that we're using the orbitals that are described in our hybridization scheme, respecting the principal quantum number on each. So we have D2, we're going to take from the 4D, 2 of these, S, we get our 4S, and all 3 of our 4P. And so these will all combine to give us our hybrids. Now, the 3D was completely untouched, and so we'll write that over the same, keeping all 10 electrons in place. We have 3 in our 4D that were left untouched, and we have 6 orbitals in our D2 sp3, and that's because we selected 1, 2, 3, 4, 5, 6. So now that we have all of that written out, the only thing left to do is to fill in the electrons, and for that we must count up how many we captured. So we have 2, 4, 6, 7 total that were captured. So we fill that in 1, 2, 3, 4, 5, 6, 7. Because all of the hybrid orbitals are on the same energy level, we have to fill in all of our spin-ups before we can go back and fill in any spin-downs. And this shows us what happens in the after picture. For bromine orbitals being hybridized.